So in this video, I'm going to revisit a topic that we've talked about quite a few times in this class. So it's a theme that's been going through, but I want to talk about it in a little bit of a different context, and that's the linear search method that we all sort of know and love, right? So normally with linear search, so we've seen this before. The basic idea is that we're scanning across an array using one or more loops, right? So if it's a two-dimensional array, we would need 2 for loops here rather than 1. And we're comparing the result at each successive location to this search variable. So we have our array and we have our search variable. If we find it, then we return true. And once we get to the end, if we haven't found it, we return false. So looks like I'm missing a semicolon here, right? And that's the basic idea. We just make a linear scan through this array. Well, what if we had a method that was provided to us by the system that had the following signature? So say we're given it's a static Boolean, so it returns true or false, and we have to give it the array here. It's of doubles and a search, right? This is the normal thing we see, and then an imin and an imax. And again, I'm missing something here. So we're given the range and the normal search and array, and it returns to us whether or not the search is found in that part of the array. So how would we, instead of using that for loop that we had on the last slide, how would we use this method to find, use this method in search in place of those loops, right? Assuming current temp and all temps are our array and search, right? Well, so you'd make the call. Our array is all temps, and that goes into array. The current temp is a single double, and then we want to search from 0 to all temps.length minus 1, right? We want to take the entire range. If this is 0, this is at.l minus 1, right? And we want to get that whole range. I don't necessarily know how linear search in range works, but I know I need to give it the range of things to look for, and it'll look for it in there and give it back. So I hope you all realize where this is going. Now we know how to use this method, so we need to write it. And these we're supposed to build in, but they don't, so that's fine. So we know how to use the method. How do we construct it? Well, the first thing, we want to make a recursive call. And so in this case, let's pretend that our recursive call, is going to be on all but the last element in the range, right? So that means we're making a call to array search. So the array and the search don't change. Everything but the last starts at the min still and ends at 1 before the max, right? And then that'll return true or false whether search is in that array, right? Is in that range of the array. And without knowing that, we also need to make sure that we check personally. So this range is going to be 1 smaller, and we need to check that last element ourselves, right? We need to do that in the current step. And then the base case is basically when nothing would be checked in the recursive call, meaning the range in the recursive call is empty. So we would stop when min equals max. Right? When there's only 1 element left, we know we just need to check that and return. So those are the ideas. How do we put that together? So here's our signature. And remember, we have the array itself, search, min, and the max. Well, the first thing we said was we needed to we needed to make a recursive call. And that recursive call was to, again, this wasn't supposed to build in. Is to the array, which doesn't change, the search, which doesn't change, the min and the max minus 1, right? And since that in itself is a Boolean as to whether it exists there, well, we could just return it, right? So that's what I had on there. It's just to return that value. What that doesn't do is that doesn't check the last element to know whether or not it exists, right? Well, so what do we need to do to determine if that last element, max, exists? Well, we need to check it. So we need an if statement, if array I max equals search. And if it does, what can we return? Well, if that's true, then we can return true. And notice that since we return true here, right? We return true here, we wouldn't even get to this. So once we've found the thing we're searching for, as we're coming from the end, if we find it, we know it's there. Otherwise, we're going to keep searching further and further in the array. Just like in the linear version, or just like in the for loop version, right? As we were going along, as we start going along, if we found it here, it doesn't matter what's there, right? Here, we're just now doing it from the end. So now we have that, and then, well, this will keep going, right? And eventually, min will be bigger than max, because max will become, say, negative, right? So we need to stop at some point. And we need to stop when the recursive call would be negative. So we're going to stop when I min equals I max, right? Because otherwise, this would become a range that's negative. And at that point, we know there's only one thing left, right? So if we go out all the way here, here's our array. And now our min and our max are here. Min, max. And we know it's nowhere in here. Well, we know that if this equals search, return true, and if it does not equal search, return false, right? Which is exactly like saying array I min equals search, right? It exactly satisfies this condition. So the question is, why did I use min here and not max? Well, does it make a difference? No, they're the same value. So this is how we implement linear search in a recursive method, right? Here we need to pass the one thing extra that we're giving it is the range, and that's just so we can keep track of what we've done and what we haven't.